Hi, everyone. Thanks again for joining us. I'll be giving you some introductions right now to our three experts in the room. First, there's Brian Partridge, actually on the line. He's VP of Mobility Research at 451 Research House. Max Myers is here. He's a government lab fellow from Deloitte Consulting. And Joe McNulty, VP of Product Marketing at Newstar. Thanks very much, and enjoy the webcast. I'll leave it to Brian to kick it off for us.
Great. Thanks, Maria, and welcome, everyone. Appreciate you joining us on an interesting topic today. We're going to, maybe we could just go back to the agenda. Just to run through the agenda, I'm going to take us through a conversation around some definition challenges and opportunities around the Internet of Things, and specifically with an eye towards the role and responsibility for trust and credibility in the advancement of these systems. And we're going to draw a string through that context setting and talk specifically, Max is going to talk specifically about the application or the potential application of Internet of Things in the public safety context. And then Joe is going to wrap us up with a discussion around how some of these concepts apply to a more mature and well-known service, caller ID. But prior to 451 Research, I was 10 years at Yankee Group, and so Yankee Group, if you're familiar with the company, is a research firm focused specifically in the telecommunications space. So from my perspective, machine-to-machine is the rightful forefather of IoT, and has in fact been a growing part of the telecom business mix for about the past 5 to 8, 10 years. For its part, IoT, I would say, is still in its infancy. So remote device access and data capture via networks is the common element between machine-to-machine and IoT. But M2M systems have been typically deployed as point solutions, with common device types, usually embedded computing modules, connected over fixed or cellular networks back to data centers. And the most common applications for these M2M systems have been remote service management and asset tracking. And importantly, the data collected from those systems is typically collected, stored, and then mined at a later time. For a lot of these reasons, trust and security has been less of a front burner concern because these systems have tended to be either proprietary, semi-closed in the OT environment. They largely remain separated from the existing IT enterprise applications, nor were they facing the open internet. IoT, for its part, is far more expansive, and so for us, a one-liner for the definition of IoT is a system of devices, networks, and applications enabling the virtualization of the physical world. So very expansive in its potential application, and frankly, game-changing for a lot of industries and for a lot of potential usage scenarios. The big difference between machine-to-machine and IoT beyond the network technology is this inclusion of cloud and big data. The economics of cloud make it the right execution environment for the Internet of Things, and big data tools and capabilities usually running in a cloud help us make sense of the immense volumes of data that we anticipate in this new world. IoT, as the name implies, anticipates heavy use of the internet as a connectivity layer, but with a very heterogeneous last mile or even last foot of networking technologies. So we've got a lot more diversity of device types creating data, and as a result creates enhanced levels of complexity when it comes down to creating secure and trusted environments. In IoT, we expect not siloed systems, but heavy integration of that data with existing IT, and really see it as a pervasive part of business operations going forward, and decision being made on this data in real time. So as the OT-based M2M systems of the past become the IT-driven systems of the future, we expect that many of the same challenges we faced in internet-connected devices around security, identity management, and privacy will come to the forefront of the conversation. In fact, they already are. And hence the topic of today's webinar, this need for trust and credibility. We're already seeing countless examples of where this is falling down. in the marketplace. You might have noticed the FTC's complaint against TrendNet, which is a maker of IP cameras, which is essentially were letting down consumers by making their IP cameras set up in the homes and for surveillance openly available through internet, through very rudimentary sort of hacking technology. So that was the first of what we anticipate will be many such actions. So to take a look at the market forces that have come together, let's take a look at this. You know, there are a lot of reasons that IoT has entered sort of the mainstream of our consciousness and conversation. Most importantly are the falling costs. So costs have come down across the board dramatically on the device. So the marginal cost to get a product talking is nearing zero, you know, sort of in the $5 range to get a Wi-Fi modem. I mentioned the cloud. So the cloud as an IT execution environment, you know, it's obviously revolutionizing the IT data stack, as it were. In traditional enterprise, it provides all of the right sort of economics and capability for dealing with IoT traffic. Although again, another layer of security concern is brought into the conversation there. Clearly, marketing efforts from IT giants like IBM, Apple, and Google are raising overall awareness, and that's across consumer and industrial. The hand of government also has a role to play here, specifically in the area of smart meter regulation, as well as in connected cars with a regulation like eCall in Europe. I'll also call out enabling technologies such as IoT middleware. I spend a lot of time dealing with that market segment and application platforms, and these platforms have made it a lot easier to integrate with cloud services. In many cases, telecom operators have either developed these capabilities in-house or partnered with people to reduce upfront costs and the complexity of getting infrastructure passing. The bad news for the telecom operators here is that the costs have come down for connectivity. The other side of that coin is that volumes have made up for that for the most part, and end-to-end service revenues are also filling the revenue gap that's around cost reductions on average revenue per connection. The question most operators are asking themselves at this point is, how do I maximize my opportunity here, specifically related to trust relationships with either enterprises or consumers or application providers that may sit downstream from them? And what are the ecosystems that I have to develop in order to support this new environment, this new business opportunity? It's vastly different than the traditional telecom business. We know that. So how do I organize myself and build the skills internally to maximize it? The next slide, we'll look at some of the possibilities. So I think we've all seen slides like this that talk about the potential for IoT really across almost all types of verticals, and as a catalyst to new business models. As I said, the point solutions of M2M were typically driven by cost savings, business drivers, and those are fine. Those continue to be important in IoT. But what's really interesting and exciting is the potential that this always-on or almost always-on connectivity to products and services bring in terms of new business models. So think pay-per-use. In the case of someone selling robotic equipment for a factory, being able to sell those robots by the hour versus asking for $1 million for them. It also opens up the opportunity for outcome-based models. So again, allowing a solution provider to say, hey, let me defray the upfront cost with you, share some of the risk, and then I'll take a piece of the back-end savings that this IoT system delivers to you. Another ancillary benefit of having connected products for OEMs is a completely new feedback loop into the R&D process, which is just incredible in terms of the improving process improvement in the actual product development life cycle. But the major step change here is we're turning product companies into data insight companies, and that's exciting. It brings all sorts of new opportunity, but it really changes the nature relationship with customers and brings these issues of trust and security that people in the data business are very understand very well to these product companies who frankly have not had to deal with these types of issues. On the non-for-profit side, there's enormous efficiencies to be had applying IoT technology in places like government and to connected citizen applications. Smart cities are popping up all over the world. By my count, there's at least 25 of these major projects underway globally. One of the most interesting ones that I got to see in person was in Barcelona, Spain. Interesting. I mean, they're literally trying to digitize almost every government service that they provide. The one that's delivered the most return was, interestingly, the parking application. And unfortunately for those citizens, it's about parking enforcement. So essentially automating the ticket writing process. But nonetheless, they're digitizing in a big way. And as Max will pick up in detail, there's a lot of opportunity to apply IoT, specifically in the area of public safety. So first, let's have a reality check, though, of where we are relative to this market. We're in the very early days. So, we've got good news is that we've got 15% of the market that are already planning to evaluate or test the technology. The bad news here is that 45% of respondents don't have any plans for the technology now, nor for the future. So this speaks to an ongoing challenge that we have to really educate the broader enterprise for the potential and value of these technologies. The next slide here provides some clues to the lack of interest currently, and really, no matter how you ask the question, security and trust comes back always number one. So unfortunately, this is a challenge of trade-offs. And the good news is that telecom operators are in an important position to leverage their brands to enable these ecosystems. The FTC would tell you, many of the industry watching groups that would say that what the big missing piece is that security and privacy are not being built into these systems from the get-go. So they're missing incredible opportunities to solve really easy challenges to solve right from the get. And another important but less talked about aspect of all this are business process changes and cultural changes that need to be dealt with as you adopt the technology. We talked about the change from a product business to a data insight business. The cultural and business process changes that drives downstream are extremely expensive. And becoming a data insight company requires the skills to do the right things with that data, bringing data scientists in, and frankly, there's a skill shortage in those areas. So again, the good news and bad news here is that security is an important aspect of a larger trust concept. So trust is somewhat of a subjective concept, but the ability to deliver a service with high quality, high availability, security, privacy, and clear transparency is what consumers are after. And so at each layer, there are roles for the different layers to play. The really interesting thing is that telecom operators and their their ecosystems have a full view of this. I would say that we're in some places we're better than others relative to the different pieces of this. Clearly, there are plenty of standards to secure data. Now, when you get to very low capability devices at the edge, you have to start to take some special steps to secure those data streams. But once you get to an internet, there's plenty of things that we can do to secure those streams. Where it gets tricky is when you start to have cloud-to-cloud, application-to-application trust environments, where really this is still the wild, wild west because we don't have a lot of usage scenarios that are really doing that. Just a quick mention of APIs. So APIs are critical to the development of this market and ecosystem, especially with an eye towards those application-to-application, cloud-to-cloud type interactions. APIs are going to be the way in which enterprises expose information and capability to their partners. And so having a security architecture around those is really important. What's, I guess, most scary about this is that we really don't know exactly what type of threat environment we're going to be looking at here. Akamai recorded a massive DDoS attack last year that was, I think it was called Spike, that actually generated about 215 gigabits of traffic. Part of the DDoS bot army there were connected devices. So ARM Cortex processors running Linux were actually part of the threat surface there. So just to draw some parallels here with IoT and caller ID services. So caller ID services are a great example where trust is really important to customer experience. Unfortunately, this has been an area that traditional telecom business has suffered a little bit and has resulted in a reduction in quality. That's either driven by poor data access on the CNAM side or much more of activity on the attack side. So despite the lack of revenue growth in core services, caller ID remains an important feature for businesses especially, and they need to know who is calling them, and they need to know who is receiving their calls. So neutral providers are important here of identity and security. Both will be in IoT and are in caller ID. These providers reduce friction and help get over this lack of trust between either telecom providers or cloud and application providers. These services, IoT and caller ID, both have horizontal appeal that expands across consumers and businesses alike. And in both cases, telecom operators really are in a catbird seat to drive some value here, and at the same time enhancing their brands as they do so. At this stage, I'm going to transition over to Joe. I'm going to transition to Max, who is going to talk specifically from Deloitte about the intersection of IoT and public safety. Joe will pick up the caller ID service topic at the end. So over to you, Max.
Thanks, Brian. So as Brian mentioned, there's definitely a lot of pieces here. Sensors, machines, other devices acting as signals and actuators. And what we really want to drill down on is to get value from this. Organizations will need to look beyond kind of the things to bring together an ecosystem that can let us know what's actually happening in the business, see, understand, and react to the world in a more real-time way. And with the volume of data that's possible, this is going to require design thinking and design around very specific problems and challenges. So I'd like to start off by just talking a bit about how to design this system to make it actionable, jump into an example or a quick illustration of how that might look in public safety, and then zoom back out a little bit to talk about kind of the business model implications or challenges. So when I start talking about public safety and connected devices, it seems to immediately conjure up these images of Skynet or RoboCop or Minority Report. In general, some general concern. I actually want to ground us to start off today in a different kind of image of public safety, and that's to follow on Brian's parking example. That's this speed feedback radar you see on the slide here. And I like this for two reasons. One, it's a great example of what I mean by designing for value, to design to change behavior and more immediately. It's a very early example and a very simple example of taking a sensing input and changing behavior based on it. These things, when they were deployed, a couple decades ago, about 10 years ago, actually reduced speeding dramatically in the areas they were used, and particularly for the highest and worst offenders, what they call the 85th percentile and above. So for those people who saw this, most of them responded very well and slowed down. And that's kind of the goal of knowing more and making it visible and adding signals, is to change that kind of behavior. I also like this because it's a great example, a very simple way to explain the potential for a device to kind of enter into a system like this. And so I want to use it as a very concrete analog for these 4 layers you see on the screen here. So we think about designing this system in 4 parts. The first part's local sensing. So what's going on? How do we use these cheap sensors Brian mentioned to find out more and figure out on the ground what's happening? And for the speed feedback radar, that's not only speed, it could also be visibility, it could, congestion of traffic, current conditions where that is. And then you take those inputs and you wrap them all up, and that's that network piece, data integration. How do we aggregate that and map it not only to those local conditions, but also things like time or weather, a little more general conditions from other sensors and other sources. Bring those all together and then apply amplified analytics. So this can be learning algorithms. It could be as simple as a predetermined formula that could say, hey, given low visibility, time of day, it's nighttime, and poor weather, that top number shouldn't be as fast as it is. We actually need to adjust the speed limit to be a bit lower. Or it could be more complex and begin to start to hotspot and determine where a future event might occur. And so there's this idea of adding amplified analytics, and this is where you get the idea of smart devices, right? Making it much smarter in terms of what it's able to do. And then what do you do with that? And so real-time signals is how we communicate that back into the system so people can act on that information. So what are you flashing? Are you changing the top number? Are you changing the bottom number? Are you signaling law enforcement, that kind of thing? How are we going to use that information immediately rather than looking back on it a week later and saying, yep, when it rains, we have more accidents? How can we actually act more immediately to prevent those accidents? So 4 layers, what's going on? How do we put that together with a lot of other information? How do we know what's going on without a lot of human input? And then how can we flip that back to change behavior? So what's that look like? What's this capability allow us to do? And I really want to jump into, as I said, the goal is to kind of design around a challenge or a problem. And so I want to look at real briefly at how this could solve challenges in public safety. So how can we use these capabilities, these 4 parts, to solve a challenge? And the challenge that I'd like to focus on is emergency response. So when we think about government and think about public safety, we think about emergency response as one area of information asymmetry, or where we don't always know as much as we'd like to, as fast as we'd like to. It depends heavily on those involved to report quickly and to report fully to the authorities and get help. And as a result, public safety organizations often have to balance speed and context. Do we know what's going on, and can we get there fast enough? For example, in Los Angeles in 2011, they found that only 15% of emergencies reported were actually able to be responded to within the policy of 60 seconds. So in other words, 85% of 911 calls took over a minute to dispatch to the right department with the right information. And a lot of that's collecting details. What's going on? Where is it at? What's the real challenge? So we believe that the Internet of Things in redesign work actually offers several opportunities to redesign work. So it can automate some of that to make it quicker. It can enhance the responders' capabilities, and it can help build the ecosystem to get more people involved. So how does that look? So if you look at, just take a neighborhood, for example, you see several different elements of that. You might see, the people involved. You might see kind of the responders, and you might see the environment. So looking at each of these roles, I want to focus first on how we could automate things, and that's kind of getting into the environment. So, so imagining very quickly with the environment, what can it detect and tell us is going on? Sorry, slides there. There we go. So what can it tell us is going on, and how do we know what's happening? And so for one example, it might be, imagine that you're in California with a wildfire. Early detection, maybe around the perimeter of a neighborhood, could detect that a fire is coming in that direction and automatically shut off windows and vents to prevent the effect of fire inside the house, even as it alerts authorities. So beginning to do some of the things that responders would do when they first got there, by connecting all these different devices, you can actually automate that process. Or, as responders come out, one challenge is location. It used to be that landlines could actually tell you not only where someone was, but what floor they were on, what part of the building they might be in. You could look at the extension and find out even down to the room sometimes where the emergency was. Today we're having to look more and more. We lack that capability often today, but things like indoor beacons could allow us to do that, pinpoint a location within, say, 10 feet, 20 feet to tell us where the emergency is happening. And then there's devices we see today on the market like ShotSpotter that actually allow us to pinpoint the location of gunshots within 10 feet as well. So it's a microphone that listens to and records the sound of a gunshot and reports it back to police headquarters. They actually discovered in Camden, New Jersey, that 35% of shots fired went unreported, which is, dramatic to think about in terms of potential incidents inside city limits. So taking all that information, then how can we enhance the responders' capabilities? When we think about, we begin to think about the potential to integrate video feeds. So once we know there's an incident going on, or are confident that there might be one, someone's reported one or the environment suggested that, how can responders begin to think about what they're doing better? And this might be putting a dashboard on a live feed onto the dashboard of a car. As responders come back, they can see video from the scene and begin to know what they're walking into, which would reduce their stress level and their overall suspicion. It might also be checking their stress level. As a responder, you're entering a scene you don't know, your stress is pretty high, and monitoring when that spikes or peaks and coaching police officers or firefighters as they respond to deal with that stress over time so that there's less chance of incidents flaring up in negative ways. So you can enhance capabilities, and then finally, how can you engage more people? And this might be looking at, so now we know something's going on, we have people responding, are there other opportunities to provide help? And this is something that a group called PulsePoint has been working on for CPR, actually. So, yes, we can send a medic and an EMT out to go help with an emergency, but is there a doctor right next door? Is there even someone that knows CPR right next door that could get there faster and potentially save the life? And so how can we then use this automatic reporting in a way to let others know and kind of mobilize the community? How can we get people there faster? If there's a doctor next door, do we need to wait on an ambulance? PulsePoint, First Sign, and several other organizations are beginning to think about this. Not only how do we tell responders faster what's going on, know more about it, enhance their capability to respond, but also how do we engage more people in the community? So as you're beginning to probably sense, I'd say kind of the takeaway point is that it's not just at this point about what we connect, but also how we change business models. One thing that John Hagel, who's a principal at Deloitte with us, said was that many organizations are still deploying the IoT as a technology that can incrementally and perhaps even significantly improve performance, but it leaves the core nature of the business untouched. If you imagine the world we've described for public safety, that's more than just a better response, more than just a faster response. It begins to get into a different model of response, a more community-based model that looks at even how we do that dramatically differently. And as we think about that, for public safety, there's things like more community involvement. There's things like merging analysis and response. Typically today, analysis happens back at headquarters, responses in the field, but you're going to need to have a lot more cross-training. But kind of across verticals, across industries, perhaps one of the biggest considerations is security. And we'll need a different business model, a different mindset for how we approach security. Today, a lot of security, whether it's law enforcement or cybersecurity, is based on the idea of enforcement. How can we prevent? How can we build up a perimeter? And then how can we enforce? And there's been a lot of people, including future crimes author Mark Goodman, all the way up to FCC CIO David Bray, who have said we might need to tweak that a little bit and think more about like a public health model. How can we think about not just, how can we focus more on maybe education of consumers, early detection, and then isolation, more than prevention and enforcement, which are two very tricky and difficult things. And so how can we make sure people and consumers are more informed, more ready, and begin to build that into our business model even now? I think are some of the driving questions for security business models as we move forward. And I'll hand it over to Joe to talk about that in a more near-term sort of way.
Great. Thank you, Max. As Brian mentioned earlier, much of what we've discussed to this point with respect to trust and credibility rings true with voice calls, and unfortunately, this is not something new. So let me start by stating, with opportunity comes opportunity, meaning with so many ways to leverage and present information in a flexible way over IP networks, the number of bad actors are increasing, all with intent to hide, fool, impersonate, deceive, and defraud via phone call. Simply put, spoofing is too easy. It serves as an enabler for vishing, that's vishing with a V, it's similar to phishing in the email world, swatting, and illegal robocalls, among other issues. So it goes without saying, but I'll say it anyway, we can't let this type of challenge compromise the value and good enablement we derive from technology. And now that we've energized around the myriad of possibilities spawned by the Internet of Things, I'm going to slow things down a bit and start with something that is likely much less exciting. However, it represents a great analog to caller identification. Simply, and I apologize up front for stirring up the song in everyone's head, but who's that knocking at the door? So I think it's safe to say that our ability to identify who is knocking and why drives our response or reaction. Can I see them? Do I recognize the face? Are they alone? Can I tell what they want? If we have no visual, it's safe to say most of us would not answer. If we do have a visual, but we can't identify the face or purpose, most of us probably would not answer. By the same token, if we have a visual, but the individual looks suspicious or threatening, we are likely to not answer and maybe take additional action. If we have a visual and we can tell that they are soliciting, we are likely not to answer. And of course, if we have a visual and we know the person, we may or may not answer. Having said all that, these cases will vary depending on the level of screening or upstream security that the visitor was subjected to, such as a gate, a security guard, a doorman, etc. So let's carry this over to a voice call. I wanted to start with ring ring who's there, but I can't recall a hit song ever being produced using that phrase. So similar to answering the door, the degree to which we can identify the calling party helps us inform our response or reaction. And as well, similar to answering the door, very few of us would answer the phone with no identifying information. In other words, blank on the screen. Very few of us would answer where we don't readily recognize the information presented, such as a phone number coupled with the phone number instead of a name. We've all seen this. Most of us will answer or not when presented with familiar, complete, and trusted information. But unlike our door example, when we have a high trust in the identifying information and we decide to engage, we don't expect surprises. Examples such as a Tier 1 wireless 800 care number ringing your daughter's cell phone demanding information on the account, or the IRS calling your home phone 5 days straight from 5 different phone numbers with an urgent message indicating that you are in serious trouble if you don't contact them at a 6th number. Both are real examples that I personally have experienced in the past 6 months. So let's talk a little bit more about intent, as I believe this is really important here. As one can imagine, there's a full spectrum of reasons why someone or some entity is attempting to get you to answer the phone and engage, which means we can't just deploy solutions that result in good calls not being answered. Not all calls are created equal, and some calls that might appear as not trustworthy are actually good. So I've grouped these engagement scenarios into general segments for simplicity. They include, in general order of best to worst, friends, family, neighbors, and other individuals with whom we are familiar and trust. Those folks may call. Maybe we expected them to call, maybe we didn't, but normally we're going to answer those. Of course, it might be someone you don't want to talk to. And then we move down to businesses with whom we have an existing relationship and or a nonprofit entity who's looking for help from you. Moving down, once again, government and local concerns looking to alert or notify. I'll use Max's example of a forest fire where they might do this is a good example of a good robodialer where they want to get the message out within a certain geofenced area. Then we move down into more of a gray area, telemarketers, businesses, or individuals looking to solicit and get you to answer the phone. Some of the bad robodialers live here. And then moving forward into individuals looking to fool or trick but without true malicious intent. This is the swatting bucket where public resources are misled and deployed erroneously. And then into the bad actors looking to gain financially by masking behind legitimate and familiar entities. And then finally, this is starting to pop up a little bit more, really bad actors looking to defraud or harm on a larger scale. So what is needed for us to regain our trust and confidence for this valuable communications method? I'll start with the most important and most immediate need, and then move into purely value-based streams of thought. First and foremost, we need to establish a chain of trust. In other words, authentication for voice calls. The Internet Engineering Task Force, or IETF, has put a lot of work into standards covering 2 primary enablers for securing what is referred to as telephone identity. One is credentialing phone numbers using cryptographic keys, and the other is in the area of signaling to help any point along the path of a call to securely identify the originator. I'll dispense with the technical details, suffice to say that adoption and implementation won't happen overnight, and will likely follow some degree of a schedule of X percentage of numbers credentialed and X percentage of calls secured by this date, much akin to milestones established for the auto industry to reduce car emissions over so many years. But alongside that, these foundational efforts, there are other creative approaches to help combat the issue along the way, and some of these have promise. Is there intelligence derived in such a way that help predict or otherwise inform the operator of the device or the subscriber of originating party quality, such as IP address reputation, the volume of calls from a number in a given time period, X number of complaints from subscribers about that telephone number, and published list of suspect numbers, among other things. And more immediately, we should be asking additional questions such as which mainstream data sources can we rely on? Are the data sources for name and for other near future attributes such as caller preferences and or other information trusted and secure? Some of that other information might include a vanity or nickname that someone wants displayed in addition to their real name. That's just one small example. Can we rely on a single source of phone number exception list to inform quality or intent before the call terminates, sometimes referred to as black or white lists? And by extension, can devices, applications, and protocols support the delivery, unpacking, and display of more than just a 15-character name, which is traditionally what we call CNAME? Can contextual information such as location, intent, and other information related to the purpose of engagement be provided? Is it really unreasonable for me to expect the number, the person's name, the company they represent, and the purpose, for instance, in regards to your request for quote, and other attributes when an electrician responds to my inquiry? And while these are all great opportunities to provide additional value, these too will likely present themselves as potential tools in the bad actor's arsenal, unless, of course, we solve for the foundational need for trusted telephone identity. And with that, I'm going to hand it back over to Brian.
Thanks, Joe. So to wrap this up, from my perspective, the Internet of Things is going to be as transformational a technology shift as any of us see if we can get it right. And amongst those actors that need to get it right, clearly is the public safety, which Max spent some time talking about and thinking about. And we think that, in fact, those types of services in sort of the government and citizen realm are going to be amongst the first to benefit. However, IoT, as I had talked about, really requires a rethink of our existing IT and trust models. And I think the good news for the telecom operators is, as much as any time in the past, they're in a good position to add a lot of value to solve these problems, given the network ownership, the ability to develop ecosystems, and the increasing investment in software and platform assets. They are, amongst a short list of people that can actually bring that holistic view to deliver against a trust value proposition. Specifically in this business, though, it's going to require a mindset shift. So for operators who may have been reluctant to get further up the value stack to add value, that's going to be a necessity given the fact that there's significant pressure downward on bandwidth. In the context of what Joe was talking about in caller ID, we might need to really think about shifting the mindset from cost optimization and saving money to making money and actually differentiating based on our service capability as well as our position as a trusted brand. We think that those operators that can do so will differentiate themselves and as a result deliver profits. And that applies to consumers and enterprises alike. I guess so the call to action here is, what are your businesses doing to support these opportunities? And I know I'd personally love to hear that answer. So with that, I'm going to pass over to Maria, who's going to start us on the question and answer section.
Thanks, Brian, for your conclusions and your summary. I think it was very useful. So now it's time to take some Q&A from our audience. We'll wait a second to see what's coming in. So here's the first question, and we'll direct this toward Brian. In a world where there are already something like 5 billion connected devices, is it practical or even possible to sort out the good guys from the bad guys, and how would you monetize that service?
Yeah, it's very similar to the traditional internet services. It really isn't possible to stop every attack, to thwart every attempt at privacy breach. just as long as there's such thing as zero-day attacks. So bad people, bad actors will do bad things, especially when there's significant financial motivation to do so. So those financial motivations have yet to manifest themselves in the IoT space. They certainly have done in other aspects of the internet business and even in the caller ID and caller name realm. But as an industry, we need to take this step to every step we can to prevent these disruptions. And the opportunity to monetize these service for IoT service providers is about being able to stay in business, right? One major event, outage, breach of trust, of consumer trust, and it could be lights out, especially in this early part of the market. For the people behind the scenes, like telecom operators, I think there's plenty of opportunities to monetize and for services that they could be paid for. So I think of things like security audits and IoT-centric takes on traditional services like DDoS, certificate management for ID, and then providing platforms that build some of these services in. So I do think that there's money there, but for the service providers themselves, security is expected as a table stake.
Okay. The next question is for Max. You mentioned that IoT will change key elements of the business model. In the new reality you described, what are the implications for identity?
Yeah, absolutely. So I think there's like two different levels of implications. The first one I kind of alluded to in part of the automation piece, which was a lot of times today identity has been based on a phone number or an address or one piece of very static information, and a lot of that will evolve and change to become very many IP addresses as we go into the Internet of Things. And finding a way to categorize, order, and define those is important, as is providing new ways to tell where someone is or what they're doing so that you can locate in a time of emergency more quickly. So things like indoor beacon systems that have been pioneered by startups like BrainItch or Advanced 911 are going to be critical. So finding new ways to identify, more thorough ways to link to that identity is kind of the first level. I think the second level is figuring out what we mean, how identity looks and how it impacts us moving forward. So what I mean by that is there's going to be a lot more of me. In order to associate the IP address back with me, there's going to be a lot more information known about me. And defining how we control what's known about ourselves and what we're comfortable with is going to be a critical piece of that, how much control we have over our identities. It's a scary piece, and a lot of what I consider maybe personal today might have to go into that. But there's also potential, and this is going to be maybe even a further horizon, but in a world where, my voice is known, my facial recognition systems, it'd be much harder for someone to kind of spoof me at an ATM, right? It'd be much harder to impersonate me at an ATM and take my card if the bank has on file both my voice, my facial image, and my fingerprint. So in some ways, it provides us more ways to authenticate identity as well. And that could ultimately even be safer if we can figure out how to construct the right system.
Okay. And then I think we're maybe running short on time, so the last question will go to Joe. Do you see caller ID as remaining a hosted service, or will consumers eventually be able to, as Max mentioned, kind of be able to take more control over how caller ID information is displayed and tagged on their devices?
Oh, okay, thanks. I would say that it falls somewhere in the middle there, right? So you see a little bit of a move where there's some service providers out there that are pushing for subscribers to be able to take control of their information and actually kind of own it, right? But it still has to be in a secured and a trusted way. They have access to it, but then others don't have access to it. But we've found in the past, especially with residential type phones versus businesses, that a lot of crazy things happen when people get to assert what they want to be known as on the other end. And caller ID was really stood up and still is in place. It benefits the called party, right? We want to know who's calling us. Businesses don't want to see Superman on the other end of the phone. They want to see the real name, although I might want to be known as Superman to my wife, right? So those types of things, if you think about it, those are attributes and other identifiers that be linked together that could be hosted in an environment where that subscriber has control over, and possibly even it's portable, much like healthcare might be today. So you can take the same healthcare plan with you if you change jobs. It might get to that point, right? But at the end of the day, it has to be something that we can trust, and it can't be something that's not validated, that type of information. So I think it's going to lie somewhere in the middle.
Okay, great. Well, I think we're right up on our time. We'll answer any additional questions via email. So thank you, everyone, for attending today's webinar. We really appreciate it. Have a good day.